Thank you for joining. This is a networking lab demonstration. Welcome back to my video series on AWS private networking. This is the last video of the series. In it, I will be demonstrating NAT Gateway. If you have not already done so, please browse my playlist and take a look at previous videos covering VPC creation, internet gateways, subnetting, instances, routing tables, and endpoints. Let's start with a simple question. What is a NAT gateway? NAT stands for Network Address Translation, and a NAT gateway is a fully managed AWS service that allows instances in a private subnet to connect to the internet or other AWS services without exposing those instances to inbound traffic from the internet. Think of it as a secure middleman. Your private instances can reach out to the internet to download updates, access public APIs, or pull software packages, but no one from the internet can initiate a connection back to those instances. So why do we need a NAT gateway for private subnets in the first place? In AWS, private subnets are designed to isolate instances from direct internet exposure. That's a good thing from a security standpoint, but it also means those instances can't reach the internet on their own, even for something as simple as downloading an OS update. That's where the NAT gateway comes in. It allows outbound internet access only, while still keeping your instances protected from unsolicited inbound traffic. Without a NAT gateway, these private instances would be completely cut off from any external resources. To help make things a little more clear, here are just a few common networking, software engineering, and DevOps tasks that you could not do without a NAT gateway. You could not install security updates or OS patches via a package manager like yum, apt, or pip. You could not pull Docker images from public registries like Docker Hub. You could not download application dependencies during CI/CD deployments. You could not query public APIs, such as fetching currency exchange rates, weather data, or external services. You could not connect to AWS services like S3 or DynamoDB if you're not using VPC endpoints. The list goes on and on. So as you can see, NAT Gateway is truly a critical component for instances without a public IP and therefore no ability to access resources outside of its VPC. Okay, let's get started. I will begin by telling you two things. First, the NAT gateway has already been created. So in the video, I will just be running through the process that I took to create the gateway, add the gateway to the routing table, and test the gateway. Don't worry, I do a step-by-step walkthrough demo. The second thing is that this topology is a complete reconstruction from previous videos. As you know, Amazon uses a combination of usage and time-based billing. So I did tear down the private network used during previous videos and rebuilt pretty much an exact replica just for the purpose of this NAT Gateway video. The security groups did have to be changed a bit. I'll go through those changes as well. All right, here we go. Take a look at the topology. I add my NAT gateway inside of my public subnet. Everything inside of my public subnet has access to the internet gateway. And of course, the internet gateway has access to the internet. Remember that I already created the internet gateway in a previous video, so I'm okay there. After adding the NAT gateway, I only need to worry about the issue of routing. My private routing table needs to be updated so that it knows how to access the NAT gateway. When any host machine inside of the private subnet needs to access internet resources, it will be routed to the NAT gateway, and NAT will access the internet gateway. Okay, let's walk through it all. Head over to the VPC dashboard of AWS. There you will find the NAT Gateway. Once inside of the NAT Gateway option, this is what you'll see. Since I already have my NAT set up, it appears in the display, and I can click to view the configuration details. I'll go ahead and walk you through the creation. I'll click the Create NAT Gateway button located in the upper right-hand corner of the dashboard. Upon clicking the button, this page opens up. It's pretty simple. Only 4 configuration items to address. I needed to indicate a name, subnet, connectivity type, and elastic IP allocation. Okay, so I named my NAT NetLab Gateway. I indicate the public subnet. This is important. I had to place my NAT inside the public subnet, which in turn has access to the Internet Gateway. The connectivity type is also very important. I indicate public because I want to access non-AWS resources outside of my VPC. A connectivity type of private will only allow me to have access to resources within my VPC or AWS services, providing that I have configured for endpoints. And finally, I request elastic IP allocation. This process is no different than physical network configuration. AWS requires that a pool of public IP addresses be made available for address translation of the private addresses held by hosts in a private subnet. By requesting elastic IP allocation, AWS can generate a pool of public IPs ready for use for private instance internet access. I check my work and click Create. Since I already have the NAT created, I'll continue on with the walkthrough using my existing NAT. Let's move on to routing. The routing tables are also located in the VPC dashboard. Once inside of the page, this is what you'll see. I want you to draw your attention to the tables labeled Public and Private Labs. I only needed to update the private routing table. There was no need to make changes to the public lab routing table. It has a route to the Internet Gateway, and that's all that is needed for the public lab routing table. The private lab routing table, however, does need the NAT Gateway added to it. That way, hosts inside of the private subnet can be routed to the NAT and continue on the Internet Gateway. Let's go into the private routing table and see what needs to be done. Here you'll see that I have added my NAT to the private routing table. I'll show you the steps I took to do it. I first click Edit Route. Then I click Add Route. Just like for the Internet Gateway, I indicate 0.0.0.0 with a mask of 0. This is used to refer to any destination and would cover destinations outside of your network. Your target is NAT Gateway. In the next drop-down, you indicate the NAT Gateway that you just created. That's it. The Save Changes button is located in the lower right-hand side of the page. Click it and you're all done. Again, I won't save anything since I already have the gateway added. Next, I'll go over the security groups for both the public and private subnets. The two are very much different. I'll start with the private security group. For my lab inbound, I need to be able to SSH into my host machines from anywhere and allow machines to participate in network connectivity testing. To accomplish that, my inbound rules allow TCP and ICMP. Unsolicited internet traffic is not allowed. This is much different from my inbound rules of my public security group. In that group, HTTP and HTTPS traffic are allowed. That is, inbound unsolicited internet traffic can travel to public hosts. Okay, so that covers inbound private security group. For the outbound rules, I left the default. My main concern was that I could ping for network connectivity and curl resources on the web. ICMP, HTTP, and HTTPS are covered. Okay, let's review my rules for the public security group. I have inbound rules allowing TCP, ICMP, HTTP, and HTTPS. I will be able to SSH into my public instances, test connectivity, and receive internet traffic. Outbound, I left in default allowing all outgoing traffic. Let's test the NAT Gateway using AWS Instance Connect and my endpoint. I'll curl google.com. Awesome. It works. I am able to view the HTML code and embedded scripts of the google.com website. Okay, so that's the process I used to add the NAT Gateway to my lab. My hosts can now download resources, perform installations, deploy apps, all of those things that I discussed earlier, and much more. That's it for this video. Actually, that's it for the series. It has been a lot of fun putting together this demo series. Journeying through the process of moving from the world of physical routers and switches into a world where logical and virtual is king has been enlightening and rewarding. I hope you enjoyed the series. Please do browse my channel's playlist for other interesting networking demos. Goodbye for now.